Rationalizing denominators. There is a convention that fractions involving surds should have rational denominators. It is therefore considered poor form to write a fraction as 1 over root 3 or 5 over 2 root 7 or 5 over 4 take away root 7. In an earlier example, I seem to remember that we ended up with a root 2 in the denominator. Can't remember exactly what it was, but something like 3 over 4 root 2. And I pointed out that this was not a good way to leave this answer. So here we're going to look at how we should leave the answer so that the surd is not in the denominator. It is relatively straightforward to change the form of a number without changing its value. We simply multiply by 1. You know that 1 times anything is the anything. But we can write 1 in many ways. For example, you could write 1 as root 3 over root 3. The process of rewriting a number such as 1 over root 3 so that the denominator is an integer value is known as rationalizing the denominator. And with the 1 over root 3, we can do that by multiplying by 1 in this form. Because think what happens in the denominator. Root 3 times root 3 is 3. In the top 1 times root 3 is root 3. And so 1 over root 3 and root 3 over 3 are the same number, but this one is what we want. With denominators such as 2 over 3 minus root 2, we can make use of the difference of two squares, or difference of perfect squares as we often know it. And we'd multiply that by 3 plus root 2 over 3 plus root 2. Now, without going through that example in its entirety, how does that work? If you look at the denominator, we would be doing this. And that means that we would get 9 plus 3 root 2 minus 3 root 2 minus 2. And those terms cancel out, and we end up with 7. So we can do it without expanding because we'll just use the dots pattern, but that's why it works.